All right, we're going to finish up lesson 5.3, solving by factoring, by doing this last word problem. Example 6, the first 5 examples were in the first video. An engineer must increase the area of a launch pad by 75 feet squared. What distance can be added to both the length and the width of a 10-foot by 12-foot pad to meet these requirements? So we're increasing an area by 75 feet squared. So let's go ahead and draw the existing launch pad. Let's just make a sketch. So it says it's 10 by 12. Oops. 10 by 12. So this is 120 feet squared. And we want to increase, it says what distance can be added to both the length and the width. So they're trying to add the same to both. So let's add some length here. We don't know what it is, so we'll say we're going to add x there. And it's still going to be this long, but then we have to add the same thing over here, another x. And that will give us our new launch pad. And this part down here should equal 75 feet squared. There's probably a few different ways to think through this. But what we have here is we have a full, so let me put 75 feet squared is going to be in this kind of L or backward L shape here. So we want this full rectangle now to equal a total of 195 feet squared, because you got the original 120 plus the 75 feet squared. So we have a rectangle, and we know that the area of a rectangle is base times height. And so the area of our rectangle we know is 195, because we got the 120 plus the 75. That's going to equal the base. So here we have a base. So how long is this? Well, we have 12 here, and then we added on this value of x. So the base is 12x. Not 12x, I'm sorry, 12 plus x, because we added that on. And then the height, this was normally 10, but we added on this extra length here, so this is 10 plus x. And so now we have an equation that we want to solve. This is not in our standard form. We can't just see it, say x equals negative 12 or negative 10. We need a 0 over here, so we're going to multiply this out and then try to solve that quadratic. So we have 120 times, or 12 times 10 is 120. 12 times x is 12x. 10 times x is 10x. And then lastly, x times x. And so we have 195 equals, we have an x squared plus 22x plus 120. And again, in order to solve a quadratic equation, we want to get one side equal to 0. And so we'll subtract 195 from both sides. And we get 0 equals x squared plus 22x minus 75. Now let's go ahead and factor this. 75, well, that's 1 in 75, 3 in 25, 5 in 15. That might be it. And we want we have a negative here, so we're going to have x and x, which will give us the x squared. To have a negative, we need one positive and one negative. And the factors of 75, make sure we're thinking about positive and negative, that give us 22 would be a positive 25 and a negative 3. So positive 25 and negative 3, which means either x plus 25 equals 0 or x minus 3 equals 0, which this gives us x equals negative 25 or 3. Well, this is not just a pure math problem just for the sake of doing math. It's a word problem, so we have to make sure our answers make sense. So an engineer must increase the area of a launch pad by 75 feet squared. What distance can be added to both length and width? So adding a negative distance of negative 25 does not make sense. We can't add a negative distance. So this is ruled out because it doesn't even make sense. And then adding 3 does seem to make a little more sense if we add 3 and 3. And so our answer is 3 feet should be added to each dimension, the length and the width. So 3 feet. You could check this to make sure it works out. Now that you added 3 feet, bad rectangle, sorry about that. Now that we added 3 feet, this would be 15, and this would be 13. 13 times 15. Five, add the 1, 4, 0, 15, and we get 195. And that is in fact what the area should have been. So it works. So our answer is you should add 3 feet to both the length and the width to increase by 75 feet squared.